Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 17, Analyzing Residuals. Okay, so classwork. Example 1, predicting the pattern in the residual plot. Suppose you're given a scatter plot and least squares line that looks like this. So here's the scatter plot. Least squares lines going through it. The points are all very close to that, so it is a very strong relationship. Describe what you think the residual plot would look like. So this is a very strong positive relationship. So as x increases, y also increases, and they're clustered very close to this line. But as you look, I will circle these because they're below the line. And then over here, again below the line. Oh, what just happened there? Oh, I see. Okay. Above the line are all of these points. And then kind of on the line, or close to being on the line, are these points. So, in looking at those, these clusters here are down here. These are here. It looks like there's only one, but there are two there. And then this group of points are all above. And then the one I circled in black, actually there's only one that's on the line, so these two would really be above the line because they're spread out. So what does a residual plot look like? Well, remember I said in the last video, if you watched lesson, was it 16? What are we on now? Yeah, 17. So lesson 16, if you graphed it in your calculator, you were to just rotate. And so I will do that with this here. If you rotate this, okay, so I copied this over just like that. Now if I click on that and rotate it so it's horizontal, and I move it down here, and then if I could exaggerate it by making it larger, okay, that's kind of what we're doing here. So this residual plot, let me put it down here. So let me rotate it so it's horizontal. As you can see, these 2 points are here, these are here, and those are all above, and these are below except for this one here, which is right here. Now the difference between this and this is that you can stretch this out as much as you want depending on what your scale is along this line here. So if you choose a very narrow scale with decimal places in between and you really stretch this out, then you can get these points to look further away from 0, if that makes sense. So that's kind of what we're doing here. But in other words, as we're moving from left to right, these points here were below the line, so therefore these are below the line. Then they change and they go above, and then they turn and come back down below. So it's kind of like an arch or an arc. Okay, so why is looking at the pattern in the residual plot important? Okay, well what a residual plot does is it provides another indication of the type of relationship between two variables. So if the residual plot, the points are all really close to 0, then you know that it's got a strong correlation. And then it also gives you better an indication as to how many points were greater than the line, the least squares line, and what points were less than the least squares line. So it kind of helps in determining the strength of the relationship. Okay, page 2 brings us to example 2, the meaning of residuals. Suppose that you have a scatter plot and that you have drawn the least squares line on your plot. Remember that the residual for a point in the scatter plot is the vertical distance of that point from the least squares line. In the previous lesson, you looked at a scatter plot showing how fuel efficiency was related to curb weight for 5 compact cars. The scatter plot and least squares line are shown below. So here's the least squares line, here are the scatter plots. They labeled 3 of the points A, B, and C. And as you can see, I've started by putting a line segment starting at the point and going straight up to the least squares line. This one here is a little tough because it's short, but it's supposed to be vertical. There, that's better. All right, so that is the distance. So B is very close, so the residual is very small. A is a little bit further away, C is very far away, and so it's large. So that has the largest residual of all these points, and it's the only negative residual. So it was less than they predicted. So it says, consider the following questions. What kind of residual does point A have? So since point A is above, we know it's positive, and it's a fairly large residual. It's kind of far away, so that'd be we would say a large positive residual. So point A has a large positive residual. What kind of residual does point B have? Okay, B is very close to the line. It's above, so that'd be a small positive residual. Okay, and what kind of residual does C have? Well, C is very large, and C is negative. Okay, so C has a very large negative residual. Okay, page 3 brings us to the residual plot of the last problem. Okay, so it's the car's weight and the curb weight and the residual, not the fuel efficiency. You also looked at the residual plot for this data set, and it says this point shows the residual for point A, this point shows the residual for point B, and this one shows the residual for point C. Your teacher will now show how to use a graphing calculator or graphing program to construct a scatter plot and a residual plot. Consider the following example. So now we got the calculator sitting there waiting for me, and now we're finally going to use it. So example 3 says, in using a graphing calculator to construct a residual plot. In an earlier lesson, you looked at a data set giving the shoe lengths and heights of 12 adult women. The data set is shown in the table below. So shoe length and height of the women. Inches, inches. Okay, so we turn the calculator on. Make sure your home screen is clear. Click Stat and hit Enter and make sure that's clear. If it's not, you arrow up and hit Clear and arrow down. Or if you are on this page, notice it says Clear List. So let me just show you something. Let me just say there's values in here. I'll just make some up. And like that. Let's say there's values, and let's make it even so that we don't make any mistakes. Okay, they always have to be even numbers, or equal, I should say. Okay, so we have this data set. We want to get rid of it. How do we get rid of it? We click Stat. We can now go down to 4 and hit Enter. And it says which list? Well, that was L1 and L2, so you hit second. See the L1 in blue above the number 1, so you use the blue button to get the arrow. And you hit the 1 and it will say L1, the comma is above the 7. We can do both at the same time. Second, L2, and hit Enter, and it says done. Now when I go to Stat Edit, it's blank. Go to Table, and delete all those. So I like a clean slate when I start a problem. So my table's empty, my Stat Edit is empty, my list there, and my y equals does not have an equation there. I want this to be shaded, so if you go to this page and it's not on, like that, you arrow up, you press Enter, and you arrow down. You could also go to Stat Plot Table Set Stat Plots right here, so the second y, and it says plot on, plot off, plot off, plot off. If you hit that, you can change it to off and on right here. In the type of graph, we're using a scatter, so you just leave it there. Okay. Anyhow, everything's clear, home screen's clear. Here we go. We want to enter this data. That's Stat Edit, and it's 8.9, 9.6, 9.8, 10, 10.2, 10.4, 10.6 twice, 10.5, 10.8, 11, and 11.8. So I look and I go arrow up to my last entry. There are 12 entries, and then I check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Arrow over to L2 and put the Y height in inches. So it's 61, 61, 66, 64 twice. I put 1, so I just go up 64, 64, overwrite it. 65, 65, 67, 66, 67 two more times, and then 70. And again, make sure that you have the same number of L1s as you do L2s, or you'll get an error that will say mismatch. Okay, so we use a calculator to construct a scatter plot with a least squares line. Well, what we have just done there is done the scatter plots. Now if I hit zoom and number 9 for stat, there's my scatter plot of this data. But I want the least squares line now. So that, to calculate that, I press stat, arrow to the right for calculate. Number 4 is linear regression. We want our x to come from L1, our y to come from L2, so we just enter, make sure that that's there, and then go through and click calculate. It gives us our a, which is our rate of change, and our b is our y-intercept. Now we want to copy this data and paste it. We don't want to write this down and then go over and plug it into y. We just have to go to y equals. Practice this a few times. You will memorize it. It's very easy. Vars, statistics we're dealing with, and arrow over to EQ, and reg EQ is the first one, and boom, it is in there. So if I arrow to the left, you will see that I got the value in there. 3.146911519, blah, blah, blah. It goes way out. There's my x plus my constant of 32.67946. Okay, it doesn't round, so it's more accurate. Okay, so now when I hit zoom 9, there's my least squares regression line. Okay, so we did this before. Hopefully that was a review and you understood how to do it without following my steps. You have to memorize those steps. So now we're going to do a residual plot. And the residual plot is pretty simple. We've already got all the data entered. We want to go to y equals for starters. I don't want my least squares line to plot this time, because if you look at this graph here, the least squares line would be shooting up through here. It might not even be on the screen because we're going to be using a different window, but I'm going to turn it off anyway. I don't want to see that line anywhere. So to turn off an equation without deleting it, you just go over to the equal sign and press enter. And then when you arrow off of it, the equal sign is no longer shaded, which means it's not being chosen. And now I want to go up and turn my plot 1 off. I do not want plot 1 to graph. Now I go to second stat plot, which is y equals. So my plot 1 is off, but now I want to use plot 2. And I go in here and I want to turn it on. So I press on. You see that we're on plot 2. We turn it on. Arrow down. It's already chosen for scatter plot. Great. And yours probably says L2 right here, like so. So it says X list L1, Y list L2. Well, we don't want L2. We want the residual. And the calculator will do that for us. So when we want to change it to residual for our Y, as it shows here, residual in the y-axis, we go to y list and change that L2. We want to go to list, which is over stats. We want to hit second list, which is right here. And number 7 is resid. So this is how you choose your columns in your table. But we're going to choose 7 for residual. And now it says resid. So now I'm going to go to my home screen. And I'm going to graph, and I just want to show you something. The graph is now where all those points were, and there's nothing showing, because we just used residual, and the values are just -6, -4, -2, up to 6, for example. Well, this one's going to have different residuals, but I'm just saying that the residual is a lot smaller than the actual value, so the window's in the wrong location. So you want to hit zoom, and just to show you, number 9 says zoom stat. And when I do that, There is my residual graph with the residual line going through it. Okay? Hopefully you get that. If you want to go through it again, backtrack in the video and watch it again. Page 4 brings us to the end of lesson 17. Review the lesson summary and go to your problem set.